So not every project is going to require every single technology, right? You want to really get away with the least amount that you need to deploy for the questions that you have and the information that you need to get. So just to kind of go through a little bit of, in a little bit more detail, some of these: environmental DNA, really great way of sampling the whole kind of tree of life by soil or water or even now air samples, where we're taking samples from the environment, extracting DNA, amplifying it, putting it through bioinformatic processes and metabarcoding protocols to basically match up the DNA bits that you find in the sample with reference DNA reference libraries of species that we already know, to match up and say, like, this is a beaver and this is a moose and this is this insect. So the real benefit is that you can go across the tree of life, right? Fungi, plants, invertebrates, a lot of species that are not well captured in other types of, with other types of technologies. So this can be really, really helpful, but it is not necessarily place-based, right? So you don't know whether that animal actually was where that sample was taken place, or if it was, upstream and the DNA was carried down by water. You don't know if it was there yesterday or 2 weeks ago, right? There's not really a way to get at like individual identification. So really good for kind of broad biodiversity baselines, but if you need a bit more nuance, it might not be the best option. Acoustics, as I mentioned, are very good for vocal species, obviously, like the ruffed lemurs. I promised that there would be animal calls, so as promised. I hope that's playing.
Yes, it is.
Great.
Beautiful.
So they sound like little demons.
Mm-hmm.
And so for vocal species, really good, because each species and even individuals can have their own acoustic signature. So we can actually get below the species level as well. But not every species is vocal. Some species that aren't as vocal might be better suited to be captured on camera traps, which are good for, small to large mammals or ground-dwelling birds. You can obviously put camera traps arboreally in trees as well, like this one up here that's showing this putty-nosed monkey. But a lot of what camera traps are really good for is a species like hoofed animals, big cats or predators, large mammals, small mammals like voles and any small kind of critter. So this is kind of another way of capturing a different subset of animals. With bioacoustics and camera traps, you have, right, like a timestamp, location stamp. It's a bit more kind of auditable, and because you have this archive of data. So that's one of the pros. Another pro with camera trapping especially, you can estimate densities. You can do individual ID, particularly for marked animals that have stripes or spots. And this can happen underwater as well, right? With doing like analysis of fins for marine mammals, or spots like whale sharks. So that's kind of one of the benefits of using things like camera traps, is that ability to estimate density and abundance. Again, just to realize the breadth of animals that make noise. This is, if you want to think to yourself, give a guess.
I want to see that. No. Okay.
So that is the aptly named musician wren, which sounds very melodic. And these microphones can also be put under the water. Well, hydrophones can be used underwater as well to get at things like this. So that is a beluga whale.
Oh.
So there's a really wide variety of animals that we can understand acoustically, including ones that we can't hear ourselves, like bats, which call in the ultrasonic, but we have ultrasonic recorders that can hear them. As I mentioned, drones can themselves be kind of a conduit to integrating sensors together. You can put LiDAR, thermal cameras, acoustics, acoustic recorders. You can have swabs, arms that come from the drone that swab for, for eDNA samples. And this was a lot of the work that was done, as I mentioned, with the Rainforest X Prize. So these are some of the prototypes that they were using there. And I really like this kind of as a kind of comprehensive overview of all of the different technologies and kind of what they're being used for. Something I haven't mentioned a lot as well is just environmental sensors, right? Weather stations, pH monitors, soil probes. All of that is kind of an additional suite of technologies that we can use to understand the ecosystem condition around us. So we're really spoiled for choice around using all of these technologies, and it's really now becoming a case of what are the specific technologies that are going to be the most effective for a particular use case, right? So it's kind of getting down to what specific data do you need and what is the easiest way or the easiest sensor that is going to give you that data for that use case.